Well, hello everybody, and welcome into the Great Atmosphere Show here on January 9th of 24. I just wanted, before we get started here on this crazy severe weather day, just want to make sure that I remind everyone to subscribe to the channel in case you already haven't. Um, this is I want to morph this channel into more of a weather weenies channel for the southeast. So for not necessarily people that have a specific background in meteorology, but they certainly have a little bit more of a learned interest than just watching a broadcast. This is kind of the channel that I'm kind of aiming for as I hone in on the scope of what I'm trying to accomplish here. So. Taking a look at what's going on here in the southeast today. Pretty crazy, severe setup that has evolved over the course of the past 24 hours. You can see the current lightning tracks coming from the main squall that we are dealing with today. Majority of the convection, I would say, or the severe lightning and most of the severe thunderstorm warnings thus far today have come from Florida, southern Georgia, but we are starting to see a lot more development, as we predicted, in the upstate of South Carolina and the foothills of North Carolina. Taking a look quickly at our all hazards index, you can see that it's still quite colorful today. We have our blizzards still ongoing in the Pacific Northwest, freezing down in the excuse me, the SoCal and southern Arizona regions. High wind warnings throughout the entire southeast U.S. all the way to central Texas. Winter storm warning in the Midwest. Some pretty high accumulating snowfall totals there. Kudos also to Maine as well, with the high snowfall totals, high winds in all of the over the course of the entire Appalachian chain. And flash flood warnings, or not flash flood warnings, the flash flood warnings are denoted by these oblong light green shapes throughout. You'll mainly see those in major river tributaries and whatnot. But you'll have flood advisories, excuse me, going all the way up from New England, or all the way from the Atlanta region all the way up to New England. It's going to be a little bit of a different form of video today. Typically, I get more into the 5 to 7 day range. We're not going to be looking at 5 to 7 pretty much at all. We'll definitely have plenty of time to do that tomorrow. Today, I just want to do a little bit more of a nowcast severe kind of video. So this is the radar reflectivity that we have seen over the contiguous U.S. over the course of the past 36 hours. You can see the primary concern from yesterday was the lower Mississippi, southern Louisiana, Mobile Bay region, Panhandle, Florida. Yesterday, in terms of what we were expecting for severe weather. Thankfully, that nocturnal event did not turn out to be as severe as we were initially fearing. So that's a good thing. The problem is it seems to have enhanced a little bit more of the southern flow that's going to be affecting us here in the southeast today. So a little bit of column A, a little bit of column B. Glad everyone generally made it out okay with in the deep south, but we got now bigger fish to fry here in the southeast. You can see at this hour it's about 12:30 Eastern time here. The primary squall line has made its way through central Georgia. It is now making its way into the upstate of South Carolina and propagating further up and further north than probably otherwise expected into the Piedmont of North Carolina, and probably will start touching the Piedmont of Virginia as well. Probably the main issue that a lot of forecasters are dreading today is the moisture transport. This is kind of the first time that we've seen it's being dubbed a East Coast atmospheric river. Now, normally we see this, like, we'll see a big parent high out here in the west, and we'll see a huge, almost jet-like, or pretty much a low-level jet, come out of the Pacific and go and just stream like a literal atmospheric river into the Cascades and the Sierra Nevada. Generally speaking, we usually don't get that type of forcing, just because the high that we typically associate in the Atlantic Ocean and this time of year is generally either usually way up here or very weak over here. Not the case in this scenario. The high has kind of reformed itself a little bit, about 500 miles north of Bermuda, and it's helping to advect a lot more moisture into our region all the way up. So you can see these are dew point values. You can see the dry cold air that is pushing and shunting underneath the or behind the system, and the main squall you can is here in central Georgia. Look at this. We got in Athens, we have a 62 dew point in Athens, Georgia, and just probably about 45 minutes away in Dahlonega, 46. I mean, that's quite considerable. And when you have gradients that are that tightly wound together is when you really get quite a bit of severe weather. I just want to take a look quickly at what is kind of the problem here. And when you have that kind of moisture transport going further up the eastern seaboard, this is very different than what it was yesterday. This also, by the way, is the NATOcast machine learning tornado index. So essentially what this does, it's been going on and learning for about 3 or 4 years now, and it will kind of discern its own probabilities for tornado chances based off a variety of indexes throughout the course of its lifetime, and it's becoming a little bit more and more accurate throughout the course of its time being here, this machine learning model. And you can see it's putting out its own SPC-like hatches. Remember, hatches is a 10% chance of an EF2 plus tornado, which would be a considerable threat to life and property. You can see that this barely, it was more east and it was more south yesterday. Not the case today. It has moved over into the greater Charlotte metro region, which is a problem, and then some yellow has made its way into the RDU region, with even some lower chances being pushed up into the central Piedmont. The majority of South Carolina also under the gun, and then as we're getting kind of into the main problem time of the day, at least for South Carolina and the western portions of North Carolina and Georgia, we're looking at about 12 to 3 p.m. today is going to be the major threat region time frame, and then from 3 p.m. to about 7 for the rest of the East Coast, or the Southeast Coast, I should say. Other big major playmaker today will be the last 72 hours of precipitation. Drought buster completely. It might be a little bit too much rain to be considered a drought buster. A lot of runoff will occur from just the amounts that we're getting in some of these spaces. Like here in the Montgomery region, they got hammered earlier this morning, about 5 to 6 inches of rain in the river basin surrounding the city, with some flash flooding certainly happening there. And then in southern Georgia and around the airport and the speedway, got quite a bit of rain here in the later parts of the morning, and now we're starting to get those values appear in the Nantahala region, the southwestern North Carolina region, and the upstate of South Carolina on those eastward facing slopes to compensate for isentropic lift and orographic lift. Taking a look at these storm prediction centers, currently reported storm reports. We can refresh the page just real quick. Yep. So you see these blues. These are official reports of high wind damage that have occurred today. And then there's some reports of tornadoes that have occurred in the Panhandle and far southwestern Georgia. Panama City, Florida got hit pretty well. I have a colleague that works at WJHJ in Panama City. They were predicting low to medium risk of tornadoes, and they got a little bit burned for it. Panama City got hit with what looks like about EF0, EF1 damage. A water spout came onshore and became a full-fledged tornado. Water spouts are tornadoes inherently, but they are generally much easier to look at, or much more interesting to look at, because they're out to sea and they're easy to see. But they're just as dangerous if obviously they come on shore, and unfortunately one did. And from what I understand, no one was hurt, but certainly some property damage was done there. If I find some pictures, I'll definitely show them towards the end of the video. Taking a look at the moisture transport and the precipitable water amounts that we are looking at, and these are the primary issues that we're seeing. This also is the SPC mesoscale analysis site. This is, generally speaking, where you want to be in terms of nowcasting whenever a storm is like imminently going to be on top of you. This is generally this is like the best live reading that you can get of the atmosphere from a numerical weather prediction model basis. These are insane PWatt values for the winter. 1.6 cubic or 1.6 inches of water per cubic meter in the atmosphere is nuts for January, specifically in this region. When it's cold outside, the atmosphere has a hard time holding in its water, just because when things are colder, air molecules are denser, and thus there is not enough room in between those molecules for the bigger water vapor molecules to exist, and thus the amount that the atmosphere can hold in terms of H2O is much lower. Somehow, some way, the convection has become so virulent in this scenario that we're getting PWatt values that are far exceeding our normal numbers for the season. So this is definitely going to be a significant flash flood threat in all the major rivers and tributaries in greater South Carolina and the Piedmont and coastal plain in North Carolina going into today. Also, just want to take a look. I'm just going to kind of jump around in some of these composite indices on the SPC. So this is the significant tornado parameter, the STP, with respect to 0 to 500 meters storm relative felicity within the effective inflow layer, and the mixed layer convective inhibition. So essentially what this is just showing the greatest probability for an EF2 tornado. Not saying there's going to be one, but if there was one, this would certainly be an environment that's conducive. So currently around the Big Bend region of Florida, that's what they're currently fearing at the moment, from what I could tell from radar. Luckily, nothing has really occurred at the moment. This is a little bit of a problem area for me in terms of waterspout formation, specifically later on into the day as we get closer into the Myrtle Beach and Wilmington coast. If this, we can go and maybe see some water vapor here. Let's do lower level vapor. Wow, that's a lot of lower level water vapor. Usually there's not this much, and you can see the perturbations of the squall too. That's kind of nutty. So there's definitely a lot of transport happening. If that transport starts to feed in from the Gulf Stream, which we are expecting it to do, we can definitely expect some tornado tracks that are going to go in this general direction. Later on in the day, probably a little bit more of a threat to the Outer Banks and the Wilmington area, Wrightsville Beach, Atlantic Beach, Morehead City. I'm sure Morehead City National Weather Service office is all over this. So we'll just kind of jump around and see what we're looking at here. We're specifically going to look for things in terms of rotation of the lowest levels of the atmosphere. So you'll see me kind of jump to surface to 3 kilometer or surface to 1 kilometer or 500 meters. Any of the breadths are obviously not great for us to be a part of. Let's see what else we got. These are the multi-parameter fields, so they're a little bit harder to read, but they definitely have a story to tell. None of the hail and derecho threat is not necessarily there. Energy helicity would probably be a good thing to see. Okay, so energy EHI is definitely favoring more of a Central Florida threat in terms of rotation. Let's go on to significant. Oh, we already looked at that. How about non-supercell tornado? Yeah, that's generally not useful in this particular scenario. We don't expect a lot of hail just because there is so much shear today, so I'm not too concerned about that. Let's do violent tornado. It's about the same as the STP instead of the VTP. And then for fun, let's see. You know what? Let's yeah. So this is we can see our current troughing that we see from the overall low pressure center, which is located up here, I believe, in the Ohio River Basin, probably in central Illinois right now. You can see that dip where the squall is, and that's where our primary perturbation is appearing. And then before we I just want to do a little bit of a radar check as well after this, but I want to get a understanding of timing as we move forward. Probably want to zoom out just a little bit more on a regional basis. Mid-Atlantic, will that do it? Yeah, that'll probably do it. Okay, so we're going to take a look at some of our, notice that we're not looking at the GFS or the Euro here. We're going to look at more of our convection allowing models, such as the high resolution NAM 3 kilometer and the HRRR or the HRR. Those are the models And we might look at the wrap here in a little bit as well, because that's what the SPC uses, just to kind of get an understanding of timing and the convective mode that we're expecting coming into the southeast over the next few hours. So you can, I'm going to update to make sure that we have the latest everything. These are all probabilities as well. This is not like a snapshot of the future in terms of what the radar is necessarily going to look like. This is just what we are expecting. So this period that it's showing has already happened. This is kind of where we are at right now. So I tell you what the problem is and what's going to be an issue going forward in the next few hours is you see these little dots of yellow and red. These are discrete thunderstorms, and when you have those little tiny supercells that form in such a convective and moist and warm environment that is heavily sheared as it is, that is just the primo, like cream of the crop when it comes to tornado formation for this neck of the woods. And the fact that the convective mode is showing that we're seeing that linear squall, we're definitely getting a good signal there from the NAM. But the fact that we're seeing a lot of these dots is quite concerning. And then in terms of timing, moving forward, so where are we at here? So it looks like it pretty much clears the coast by 5Z, which is midnight tonight. So we're out of the clear pretty much at the end of the day, literally. But in terms of major metro areas, Charlotte is getting the brunt of it right now. There looks to be a little bit of weakening. I can tell from looking at the radar here in my other screen, which I'll show you here in a second, which is a good thing. But I do expect a little bit more strengthening as the primary moisture transport comes from the Gulf Stream and not from it's currently being cut off due to Florida in the Gulf. And that's probably why there's a little bit of weakening going on. Not much, but there is. And then later in the afternoon, probably around 3 or 4 in the afternoon, maybe a little bit further into the evening, 6 p.m., 7 p.m. is when it moves into the RDU region, followed quickly after by Greenville, North Carolina, and into Wilmington. As far as South Carolina and pretty much my main concern when I interned at National Weather Service, Columbia, and I did quite a few different storyboarding projects on some past severe events when I was working there. And the one thing that I noticed was that there's one particular region of South Carolina that is like super prone to getting these tornadic discrete supercells. And that is the Orangeburg and Bamberg County regions of South Carolina, which is just south of Columbia, just north of Charleston right here. I'd be very concerned about that region as we move forward in the next couple of hours. And then we're going to move forward just a little bit more. And you see that 540 line, which we talked about in an earlier video. Look at that. It's all the way down here it's barely almost touching the Gulf. That is some cold air, cold, dry air. And that's why we're seeing, look at that, we're seeing light snow flurries and showers in Huntsville, Alabama, all through Nashville is probably going to get some kind of accumulation going into this evening. Really interesting stuff. And that's hopefully that cold air stays, but we know for a fact it's not because we have warm air advection that's going to be pushing through. Still, though, man, what a potent, powerful system. All right, let's do a quick check of some radar analysis that we have. So this is what we are currently looking at. This is Radar Omega, which is a standalone radar product. Looking at the full scope of the MRMS radar system. Let's see what it looks like over the course of the past couple of hours. You see these red boxes are denoted by tornado warnings. The yellows are severe thunderstorm warnings, and the green are flash flood warnings. Flash flood warnings were expected to come here south of Asheville, but they actually have extended down into the GSP region. Gaffney looks like for most of the upstate of South Carolina, they got, as we talked about earlier, they got dumped on just a couple of hours ago. So, and they're still getting dumped on here. So that's going to be a interesting river flooding event to track there. Severe thunderstorm warning here in North Charlotte. into the Huntersville, looks like Lincolnton, Denver region. 60-mile-an-hour wind gusts expected, no hail. You can see what the full, the full scope of the warning is. Let's see. Moving northeast at 80 miles an hour. That is another significant thing to probably mention. When these tornado warnings come out, inherently in the southeast, it is true we don't get the strongest of tornadoes. There's just not enough. There's just not enough forcing and open air, or lack of friction, I guess is the best way to put it. From you get trees and you get foothills, which is not stuff that you have in the Great Plains, which is why you get these giant tornadoes. When a storm is moving this fast, you can essentially add that 80 miles an hour to the fastest side of the tornado. So if a tornado has wind speed on its fastest side of 120, which is not a very significant amount for a tornado, if it's moving at 80 miles an hour, well, that all of a sudden becomes 200 miles an hour, and that's a very significant tornado in terms of damage. So that's kind of the catch-22 in terms of rating these tornadoes. They don't. It's very relative based off of the storm relative speed of the system itself. Let's take a look at maybe some things to look at in terms of couplets. I'm going to get down to the individual radars here. Let's see what Valdosta radar is showing. So what we're looking for here are little hooks in the system. Can't really tell per se. There might be a little something right here. Actually, this dime right here is probably what the Jacksonville office is looking at for southern Georgia. And then we have one little couplet right here. But I would assume that this tiny little thing is what they're looking at. Is this observed or is it radar indicated? Yeah, they're both radar indicated. So that's a good thing. When you see observed or you see PDS observed, PDS standing for potentially dangerous situation, that would be a problem. But the main thing we look at for is the velocity. So essentially what velocity does, and this is how most forecasters track their tornadoes, is you'll see here's the radar. Any wind that is coming towards the radar is denoted in green, and any wind that is going away from the radar is denoted in red. So it might look like with this line right here that they're converging like a front, but that is not the case. It's just that the wind is generally just going in this direction, and the radar just happens to be right here. So that's what it's denoted as. But that's a really good way of denoting. Rotation in the storm system, just because, the higher reds and yellows denote wind speed, just like the lighter greens to darker greens denote wind speed as well. So reds will denote lower wind speed, and the yellows will denote higher wind speed. And this is definitely a couplet to watch, just because there's lower wind speed on this front. It's still obviously high because it's red, but on the most damaging side of the tornado, on the southern and the eastern part of it, you can see that there is quite a bit of rotation and disparity between the two, very close together on one another. So those seem to be the only major tornado warnings that are currently in effect. I would expect a lot more to come as we go forward into the day. Specifically, I'm getting more and more concerned about north central Florida, and then also I'll be definitely concerned about the Piedmont of South Carolina and the coastal plain of North Carolina. Nothing much to talk about in this respect right here. You can see where the squall currently lies, currently going through the Gastonia, Belmont, Stanley regions in Lincoln County, and then it's going to be moving into the Charlotte region here in probably the next 10 to 20 minutes. I have some work colleagues right now that are going through it at the moment, and they say they've had several big branches come down. So definitely something to watch out for in this particular region. And then let's just keep on jumping around to see what we see here. Another thing to look for when you're tracking tornadoes is correlation coefficient. So essentially this tracks different types of things that are in the atmosphere. So like if a tornado, like it'll right around here, you see these grays. That'll denote that it's kind of the same things that are just floating around in the atmosphere that the radar is detecting. But in this scenario, we're looking for signatures that are different from that. So another thing that might lend credence to there might be some kind of spin, some kind of something going on here that's reaching the surface. Hopefully not, but could be, is that you see the beginning of these streaks begins right in the center of these tornado TWs right here. So could be that there's something on the ground that's pushing some debris and whatnot up into the atmosphere. We don't necessarily see that for sure at the moment. And I think things are a little bit too dirty up here. Yeah, it's pretty much just all rain, thankfully. I don't believe the KCLT radar has that capability. And then we'll take a look back. It's at velocity. Winds still coming out of due south-southeast, which is our primary moisture transport vector at the moment. That'll change quite a bit throughout the day. So yes, quite a I don't want to say unique, but certainly a very rare event that we're experiencing right now today. We do get severe weather at all times of year in different convective modes. This is one I would probably attribute more to a springtime event that I would. Not saying that spring is right around the corner by any means. There's certainly a lot of cold air to come in the next week or so down here in the southeast. But certainly something that we typically see in the spring in terms of convective mode. And because of that disparity in temperature and wind and moisture and shear, we have quite a significant squall on our hands over the next few hours to deal with. So hopefully everyone stays safe. Pay attention to your local broadcasters or National Weather Service office if you can, to make sure that you're getting the most accurate information as possible, so you can make the most informed decision going forward throughout the course of your day. And definitely make sure to have any safety equipment and whatnot in place as well. Make sure you have a safe space within your house if you either have a basement or an area in your bottom floor of your home with 4 solid walls that are around you, no windows. Preferably, one thing that I definitely advocate for in terms of having for tornado safety is not only a mattress to put over you, but also if you have like a bike helmet to wear. Honestly, that has saved more lives than anything, because ultimately things falling on people's heads is what it unfortunately is the cause of a lot of fatalities in tornadic situations, and just by sheer having a simple bike helmet can reduce fatality rates by some 60-70% from some papers that I've read. So even something as simple as that can help. And definitely err on the side of caution if you're under that tornado warning. One thing I definitely probably should talk about is the difference between a tornado watch and a tornado warning before I leave here. So tornado watch warning cupcake. Now, one of the meteorologists that's here in the Charlotte region, his name is Brad Panovich. He's an exceptional broadcaster, an exceptional meteorologist. He came up with this analogy to determine what the difference is between a tornado watch and a tornado warning, because it's something that is kind of a little bit of a convoluted subject in terms of messaging from the National Weather Service. So essentially, when you have a watch of any kind, you have your butter, your flour, your sugar. You have your eggs, everything that you would need to create a cupcake. But do you have a cupcake? Can you eat a cupcake in a cupcake watch? No. You have all the ingredients to make one. Like all of those things together equals cupcake. But until they are together, they are just ingredients. They are not a cupcake. And then you have a cupcake warning. That cupcake is already made. That cupcake is delicious, and it's already right in your face, and it is fully formed, baked, and ready to go. This is a warning that a cupcake is in our midst. So, conditions favorable, ingredients available for a cupcake/tornado. Tornado's here. Tornado's here. It's either been indicated by a radar or it's been observed by a spotter. And sometimes its severity has been observed as well. So keep that in mind. Cupcake watch, ingredients. Cupcake warning. Cupcake is here. Tornado's here. Okay. All I had to say there. But definitely keep an eye out and to be weather aware. And honestly, enjoy the day. It's a unique weather experience. Have fun with it. Don't put yourself in harm's way if you don't know what you're doing. But make sure to look outside the windows. Be fascinated by it. This is cool science. So definitely pay attention to that. This has been Great Atmosphere. I'm Zach, and I'll see you tomorrow for some more short, medium, or I'll say medium to long range forecasting going into next week, and see what other storm systems are coming our way in the medium term. Take care, everybody.